Let's start chapter number 2, withdrawals. In the previous chapter, we learned how to send Ether to a contract. So what happened after you send it? After you send Ether to a contract, it gets stored in the contract's Ethereum account, and it will be trapped here unless you add a function to withdraw the Ether from the contract. You can write a function to withdraw Ether from the contract as follows. Contract name is got get paid and is inherited from ownable. Then there is a function of withdraw with the external modifier and only owner. Here we have created a variable, local variable as an address, and also add a payable keyword here and write it underscore owner. And address is equal to uint 160, convert it to uint 160, and then the owner of the contract address. Then we will just write a line owner.transfer addresses dot balance. Now let's see the description. Now that we are using owner and only owner from the ownable contract, assuming that was imported. It is important to note that you cannot transfer Ether to an address unless that address is type address payable. Here, we cannot transfer Ether to that particular address unless we define it like this. But the underscore variable is of type uint160, meaning that we must explicitly cast it to address payable. Once you cast the address to the uint160 to address payable, you can transfer Ether to that particular address using the transfer function here. And address this dot balance will return the total balance stored on the contract. This will going to fetch the balance. This line going to fetch the balance of the smart contract. There is a wallet balance and there is a smart contract balance. When someone puts some amount in the smart contract, then it will reside on a smart contract, not your wallet. So we have to write a function to withdraw it. So this is the function that will withdraw the smart contract amount to your wallet. Okay. Once you cast the address from your end to address payable, you can transfer Ether to that address using the transfer function address and address this dot balance will return the total balance stored on the contract. So if 100 user had paid 1 Ether to our contract, address dot balance would equal to 100 Ether. You can transfer to send funds to any Ethereum address. For example, you could have a function that transfer Ether back to the message or sender if they overpaid for an item. Here we have item 0.01 Ether message sender dot transfer message dot value minus item fee. Or in a contract with a buyer and seller, you could save the seller's address in the storage. Then when someone purchases item, transfer him the fee paid by the buyer. There it is. These are some examples of what makes Ethereum programmatically really cool. You can have decentralized marketplaces like this that aren't controlled by anyone. Now let's complete the test. Create a withdraw function in our contract which should be identical to the get paid example above. Okay, let's create a function here. It should be identical to this one. External and only owner. That's the function that we have created. The price of Ether has gone up over 110x in the past year. So while 0.001 Ether is about $1 at the time of this writing, if it goes up to 10x again, 0.001 Ether will be $10 and your game will be a lot more expensive. So it's a good idea to create a function that allow us to as the owner of the contract to set the level of fee. Okay. We are just pasting it. Now let's create a function of level of fees. So we can define a level of fee when the ether price goes up. So we can define a new level of fee rather than use that one. So let's do it. How we can do it? Create a function, set level of fee, takes a one argument uint underscore fee, and function should be external, and it should call by owner only, so no one can change except the owner of the smart contract. The function the function should set level of fee equal to fee. So just set the level of fee to underscore fee. So that's it. So these are the two tasks with subtask in second one. So we have write the code. Let's check the answer and then move on to section number 3, chapter number 3. Let's check the answer. Yes, great, it's correct. So we have completed 2 chapters. Now let's move on to chapter number 3.